And now we are on to just sort of the last topic, which has to do with the resampling approach.
Yep.
And resampling approaches are a really, really powerful tool that gives us a way to conduct hypothesis testing, either a single hypothesis test or a lot of hypothesis tests, in a way that's relatively assumption-free. So what is this all about? Well, in this lecture so far, we've assumed that we're in the scenario where we want to test some null hypothesis H naught. We have a test statistic T. And most importantly, we know, or else we feel like we can assume, the distribution of T under the null hypothesis. And that's how we were able to compute the p-value, was by knowing the distribution of the test statistic under the null hypothesis. So remember this figure from before. And the distribution of T under the null hypothesis was this yellow curve. In this particular example, the distribution of T under the null was approximately a normal distribution. But in general, depending on your null hypothesis, depending on your T statistic, that null distribution of the test statistic could be a different distribution.
And unknown, or?
It could be unknown, right? And in fact, that's the idea here, is what if this theoretical null distribution is actually unknown? We just don't know what it looks like. Or alternatively, we could make some assumptions under which we might know what it looks like, but maybe we feel a little bit weird making those assumptions because we don't really think they're going to hold.
Or we're worried they might not hold, at least.
We're worried they might not hold. We just want to do something that's a little bit more assumption-free. So one way we can do this is using a resampling type of approach. And the thing we should say about resampling approaches before we get into the details is that it's a very general framework that needs to be instantiated in a specific way depending on the type of hypothesis you're testing and the type of test statistic you're using. So today we're going to talk about what a resampling approach will look like for conducting a two-sample t-test. But in general, if you're testing a different type of null hypothesis that's not just a difference in means, or if you have a test statistic that's not just a two-sample t-test, you're going to need to figure out whether there is an appropriate resampling approach for you and also what that resampling approach looks like. So this is going to really require some hard thinking, and it's not plug and play the way that a lot of things that we've seen so far in this lecture are. So the idea is, suppose that we want to test the null hypothesis that the mean in one group equals the mean in another group versus the alternative that they're unequal. And here we have n sub x independent observations from x and n sub y independent observations from y. Well then, as we've already seen today, the two-sample t-statistic takes the form of just the sample mean in group x minus the sample mean in group y divided by an estimate of the standard deviation between mu x minus mu y. And if nx and ny are large, then as we've already said, t approximately follows a normal 0-1 distribution under the null hypothesis. But what happens if nx and ny are small? Well, in that case, we actually don't know the theoretical null distribution of t unless we make further assumptions about the distribution of the data, the distribution of the x's and the y's. So what we can do is we can try to take a resampling approach. And the idea behind a resampling approach is that instead of just like looking up in a textbook what the theoretical null distribution of t is, or taking our word for it, or deriving it yourself if that's your thing, we're actually just going to let a computer sort of simulate for us what the null distribution of t would look like under the null hypothesis.